Hi. All right, so we're going to get started. We are doing factoring day 2. And so there's two different types that we're going to talk about today. We have got perfect square trinomials where the numbers are going to be the same, like maybe x plus 5. And then it'd be x plus 5 squared. So you'd have two parentheses, but there's a pattern. And so you can end up figuring out, if you don't feel like foiling, the pattern is, you square the first number, 2 times the first and the second number multiplied, and then the second number in the parentheses is squared. So let's practice these. Okay, we're going to do these practice problems, and your homework is on the back side. Okay, so your homework is a little combo of two things. All right, so here we go. Now, I want to know what two binomials make up this trinomial. So that's going to be, what makes 4? Well, 2 times 2. X plus 2, x plus 2. And you're done, guys. That's it. Okay, two numbers that multiply to make 9 and add up to -6. They have to be the same number. Can't be 9 and 1. So obviously it has to be 3 and 3. But then you need to figure out the signage. Remember, the pattern that we're doing today is that the signs are the same. So they're both going to be addition signs, or they're both going to be subtraction signs. Okay? Well, to make a -6 when I add them, they both have to be negative. Since I made it the zero product property where it equals 0, then x will equal positive 3. But again, you only need to write it one time. X equals 3. Okay? All right. What two numbers multiply to make 9? It has to be 3 and 3. What two numbers multiply to make 4? 2 times 2, right? Now are the signs positive or negative? Well, there's no negative in this at all, so they both have to be positive. Okay? And I could write it 3s plus 2 squared. It's easier to just write x plus 2 squared. Okay, here we go. 4 and 9. 4 is 2 times 2. 9 is 3 times 3. Right? So then I'm going to do m, and the signs, I want to multiply to make a positive 9, but it has to add up to a -12. So see how these two are so similar? So they're both the same. So I'm just going to, I don't even need to write. I'm going to do 2m minus 3 equals 0. And then solve for m. 3 halves, right? Excellent. All right, here we go. 36 and 25. 36 is 6 and 6. 25 is 5 and 5. Got it? I'm hoping that you think that this is just super easy, right? Then signage, both addition signs. So 6w plus 5 equals 0. 6w equals -5. W equals -5/6. Oh, it didn't have an equal 0. I just went too far. Sorry about that. Okay, try this one on your own. Press pause. Did you get what I got? I hope so. All right, down below. Difference of two squares, okay? So, difference of two squares is one of them is going to be positive and one of them is going to be negative, the signage. The numbers are going to be exactly the same. So you're going to notice that the perfect squares are 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. Okay? Those are my perfect squares. So then, difference of squares means one of my signs is positive, one of my signs is negative. Well, what makes 25? 25 is a perfect square. X plus 5, x minus 5. Well, if it equals 0, set both of them equal to 0. Okay? So you're done. 4x squared minus 9. 4 is 2 times 2. What's 9? 3 times 3. So plus minus. Okay, very good. 16 is a perfect square. 225. 225, guys. 15 times 15. 16. 4 and 4. Difference of squares plus minus. Okay? Even if something's written backwards, right? I can still do it. 49. 100. 10a. And then it's going to be plus minus. Okay. This last, be careful because there's a GCF. This is from like yesterday. Okay. So I'm going to factor out a 2. And when I factor out a 2 with my GCF, I get, then I have to do 9f squared minus 1. 3f, 3f, 1 and 1, plus minus. That's a little tricky, okay? All right, 64. 8 times 8, 100. 10 times 10. And it's going to be plus minus. Okay. So you set them both equal to 0. And then you solve for G. Negative 10/8. Well, reduce. Negative 5/4. Then also solve for G. Positive 5/4. Okay, something I wanted to talk to you about on the backside. This here. All this. Some of them you have to do GCF first. Like on number 15, you really need to factor out a 5 first. So some of them need GCFs, okay? Because otherwise you can't figure out how to factor them. All right? So, all right, very good. Bye, guys.